Section 4.1 Introduction to Polynomials and Polynomial Functions. We're starting a new chapter, which is going to deal a lot with polynomials and how to work with them, multiply them, factor them. To begin, let's start off with some key terms. A polynomial is a particular type of algebraic expression. A monomial is a constant or constant times some variable or variables raised to powers that are non-negative integers. Integers are whole numbers. So here we have examples of a monomial. A monomial would be something like 1, -1, z, 8x, -7y squared, 1.3p to the fourth power q to the fifth power z. That's a monomial. It's only one term. A polynomial is a monomial or combinations of sums or differences of other monomials. So like a plus b is a polynomial, so is 1/2 xz squared or y squared z minus 4x cubed z plus y cubed plus 9. The terms of a polynomial are repeated by the plus and minus signs. Coefficient of a constant term is just the constant. So 4x squared, the number 4 is a coefficient. It's that leading number. The degree of a term is a sum of exponents of the variables. These are the variables, if there are variables. So, for example, this first one, 9x to the fifth power, that 5 is a degree. The second one, remember, it can also be the sum of exponents. So if you see a lot of exponents written together, you have to add them up. So 4 plus 5 will give us that 9. That's a degree of the term. Next, we have the leading term of a polynomial is a term of highest degree. If a coefficient is called the leading coefficient, the degree of the polynomial is the same as the degree of the leading term. So here we have 3x to the fourth power plus 7x squared minus 5x plus 1. Here, x to the fourth power is the leading term. We generally arrange polynomials in one variable so that the exponents decrease from left to right. This is called descending order. A polynomial with exponents increasing from left to right is written in ascending order. So here we have a polynomial in descending order. So notice it goes from highest degree and then it works its way down. Let's do an example. Consider x to the fifth power plus 3 minus 4x cubed plus 2x to the fourth power plus 8xy squared. Arrange them in descending and then ascending order of powers. Okay, so my highest degree, think of this as 1. So this one's degree 3, 4, we have 3, no degree, and fifth power. So this one would be first, so that I have x to the fifth power. Then I have plus 2x to the fourth power. Then we have these two competing for the next place. Which one's right? Well, pick whichever one you like. They're both of the same power, so it's okay. So we have -4 minus x cubed plus 8xy squared. And lastly, we're left with the plus 3. So this is in descending order. Ascending, well, we just rearrange the order. We just start where we ended. That's where we start. So I have 3 plus 8xy squared. Then I have minus 4x cubed plus 2x to the fourth power plus x to the fifth power. Evaluating polynomial functions. A polynomial function is a function in which ordered pairs are determined by evaluation of a polynomial. So in other words, we're just plugging in a value, right? But because we're math students and working with math, we have to be proper. So we say that they're evaluating or substituting. Okay, example. For the polynomial function p of x equals 3x to the third power minus 4x plus 6, find. So I want p of 2 and p of 3. When you see p of 2, think of this as it telling you substitute in a 2. In other words, plug in 2. That's what that notation means. So let's go ahead and do that. So that we have p of 2 is equal to 3 times 2 squared, always use parentheses, minus 4 times 2 plus 6. Okay, so that we have 3, 2 squared is 4, minus 8 plus 6. Have to follow order operations, so we first had to work with that exponent. Oh, I wrote that wrong. It's a 3, right? Here we have a 3, so this should be a 3. Okay, let me backtrack a little. Okay, so we have 3 times 2 times 2 times 2 3 times. We get 8 minus 8 plus 6. 3 times 8, that gives us 24 minus 8 plus 6. All right, well, 24 minus 8 is 16, and 16 plus 6 gives us 22. So we can say that P of 2 is equal to 22. Let's work on that next one. So we see P of negative 3, it's telling us to plug in a negative 3. So that I have 3 raised to the negative 3 power, well, 3 times negative 3 raised to the third power, minus 4 times negative 3 plus 6. Okay, let's work this out. So I first have to deal with that exponent. So that I have 3 times negative 3 times negative 3 times negative 3, we get negative 27. Negative 4 times negative 3, we get positive 12 plus 6. 27 times 3, we get 81. Negative 81 plus 12 plus 6. So negative 81 plus 18, that gives me negative 63. Adding polynomials. Recall that when two terms have the same variables raised to the same power, they're called like terms or similar terms, and they can be collected or combined using the distributive laws, adding or subtracting the coefficients. The sum of two polynomials can be found by writing a plus sign between them and combining like terms. So for example, this problem, I have 3x to the fourth power plus x cubed minus 4x squared plus 6x plus 7 plus 4x to the fourth power minus 3x cubed plus 2x minus 1. All right, since we're adding these two polynomials, we can drop the parentheses and just add straight across. So let's go ahead and add them. So we have to add by like terms. Like terms means that they have the same variable with matching exponents. All right, so I see that fourth power. Those two have fourth power, so we have 3 plus 4, we get 7. 7x to the fourth power. Think of them as separating your fruits. You have to add up all the apples, all the bananas, all the grapes, all the pears. You want them counted separately. All right, now we have those x to the third powers. I have positive 1 minus 3 negative 2x cubed. Those squares, we only have one of them, so that one's just by itself. Doesn't change. My x's, we have 6x plus 2x, we get 8x. And then we have 7 minus 1 plus 6. That is our answer. Subtracting polynomials. If the sum of two polynomials is 0, they are called opposites, or additive inverses of each other. To form the opposites of a polynomial, we can think of distribution of the negative sign, or multiplying each term of the polynomial by negative 1 and removing parentheses. So we're going to multiply the negative 1 in and remove the parentheses. In this next example, we're asked to subtract x cubed minus 4x squared plus 6x plus 7 minus 3x cubed minus plus x squared minus 5. So our instructions are telling us to multiply in that negative and change the sign of each term and then drop your parentheses so that you have x to the third power minus 4x squared plus 6x plus 7, and let's multiply in that negative, which all it does is cause a sign change. So we have minus 3x cubed minus x squared, and then negative times a negative, we get plus 5. All right, let's go ahead and combine like terms. So I see I have x cubes there. So when it doesn't have a number, think of it as having a 1. Because it does have a 1. We just don't, if it's a 1, we can choose to write it or not. So I have x cubed minus 3. That gives us negative 2x cubed. That's square. Negative 4 minus 1. Think of that as a 1. We get negative 5x squared. And then this is the only one I have with an x, so plus 6x. Then we're left with 7 plus 5 plus 12. And there we have it. That's it for section 4.1, Introduction to Polynomials and Polynomial Functions.